Welcome. Today we're going to learn L'Hopital's rule. This is part 2. In our video in part 1 we introduced the rule, and today we're going to do another example. So this is our example in 1. We are trying to find the limit of this function as x approaches infinity. And if we do direct substitution, in other words we replace all the x values with infinity in this case because x is approaching infinity, we wind up with what we have in 3, infinity over infinity. And that is what we call an indeterminate form. In other words, we don't have a limit, but this specific form allows us to then use L'Hopital's rule to try to find this limit. So let's attempt that. So if we go into item 2, we've rewritten our function and our limit. And what we're going to do is obviously direct substitution does not work. So we're going to apply our rule. And what our rule allows us to do is to take the derivative of the numerator and the derivative of the denominator and find the limit of that. So in item 4, we're going to take the derivative of our numerator and we wind up with 2x plus 2. And then we're going to take the derivative of our denominator, and you can see us doing that in 5. The derivative of x plus 1 is 1, so that's what we get in item 6, you can see that. And we have now taken the derivative of our numerator and denominator. Okay, now at this point, what we do is we attempt direct substitution again. Sometimes there are certain problems where it doesn't work and you still wind up with something in an indeterminate form. That's not the case here. But if it were the case, we would then try to apply L'Hopital's rule again. In other words, we would take the derivative of the numerator and denominator a second time and see if then, when we do direct substitution, we would find our limit. Okay? Now, in this case, we don't have to do that because when we do direct substitution in 6, you'll see the numerator becomes infinity. The denominator, though, is no longer infinity. We do not have an indeterminate form. The denominator in this case is 1. It does not get affected by x because it's a constant. So that means that in item 7, the result is simply infinity. That is not an indeterminate form, and that is our answer. This is a more general form of L'Hopital's rule. In item 1, basically we're given the limit as x approaches c. And in our case today, c was infinity, but it could be anything. Okay? We're looking at the limit of f over g. F and g are both functions of x, and they are differentiable on an open interval that contains the c that we're talking about. G prime cannot equal 0 except possibly at c itself. Okay? Now, we spoke about indeterminate form. Well, if you see item 3, I've listed all the different possibilities. Today we dealt with infinity over infinity, but it could be any of these. And if you're given that, you do have the opportunity to use L'Hopital's rule. Okay, so then we've met these criteria. We go to item 4. L'Hopital's rule says that the limit of f over g as x approaches c is equal to the limit of f prime over g prime, in other words, the derivatives as x approaches c. This limit must exist or be infinite. And that is L'Hopital's rule. Now go practice, practice, and practice some more.